Well, good morning, everybody. Welcome to another edition, episode 20 of CGS Live VFX edition. Hope everybody's having a good weekend or had a good weekend. Monday morning for me here. Got my lemon and honey tea. Hopefully no coughing fits this time. Hey Audrey, how's it going? Hey, I don't know how to say your name. I'm just gonna say Saito. Good night. How's it going? It is morning here for me, despite me sitting in the dark. Today, I think I'm going to continue working on the wave shot, and I think I might finish it off today. I'm getting a little bit sick of working on it, so I might look at rendering today in Redshift and maybe Mantra as well. I'm good, Audrey. Thank you. Had a pretty good weekend. Trying to buy a house at the moment, which is stressful, but fun. It's a crazy time to be buying a house, but hopefully we find somewhere. So yeah, I don't know. I think, you know, to get this shot, let me jump to. Oh no, it's okay. It's not that stressful. I mean, it is and it isn't. It's not that bad. Doing 3D is far more stressful. So yeah, that's right. That's right. Got to think of how cool it will be. Sorry, Saito. I'm not sure. Last state. That's right. All of the lights. I'm actually going to have to build an office, I think. We're looking at a smaller place. So I'm going to have to build a studio in my backyard, which will be cool. It'll be really good. Because I can make it soundproof, which is something that I really struggle with recording tutorials. Pre-recording tutorials is the sound, and that I'm only limited to do it when, you know, there's no kids in the house and no people making noise outside. If someone's mowing the lawn or something, I have to stop. So I'm going to try and build a soundproof recording studio, which will be cool, I think. It means I can record at any time, which would be great. So I'm looking forward to that. So yeah, I'm gonna finish this. Oh, okay, cool. Let me see. Last stream I asked for suggestions. One idea that is very cool would be a classic lighthouse in the middle of a fog and strong waves and winds. That does sound cool. I'm gonna add that to my list. Thank you for the suggestion. Let's see. Where's my list here? Here we go. So, lighthouse in fog with waves and wind. Great. That's an awesome suggestion. I think I've got heaps now. Let's see. Let me bring this over. Just move this. I have earthquake, black hole, cool space effect, whatever that is, volcano, planet colliding, space debris, achievable laptop effects. I can't remember if I added that one during the stream last week or not. And then lighthouse and fog, waves and wind. I think that's pretty cool. All of these are very big projects, so I think I will do something. I will choose something that's a little smaller for the next project, just so, you know, I don't go straight into another 10-part series. I think, you know, whilst the big projects are really cool, they're also, you know, they're very involved, and they're not always what you do work on if you go and work in a studio. You don't necessarily are always working on like these big epic effects shots. I quite enjoy doing some smaller, more subtle effects as well, and more abstract things I think are really good to work on. So yeah, I might do something like that, and then you know, pick a larger project as well. But keep the suggestions coming. I think they're really good, and it gives me a lot of material to work with. So if you ever have anything that you kind of want to have a look at, or you want me to kind of explain or suggest ways of doing it, then please, please suggest them. I think doing a lighthouse is very easy to do the composition. Yeah, I agree. I think you could very easily make a pretty cool lighthouse scene with waves crashing against rocks and all sorts of cool stuff. The only issue, I guess, with doing a lighthouse scene is the simulation. The simulation of waves crashing and stuff like that. Big projects for beginners can be a really dangerous thing. A lot of beginners think they can do a 3D character. Yeah, that's right. And people think that certain things are easy, or but a lot of this stuff is really kind of challenging. So, but yeah, that's good. Thank you for the suggestion. All right, so last week I was looking at the flip simulation, and I said I was going to do a high res sim, which I did. I think it's this first one that I did. So this, you see, has a lot of points. So this has 11 million points on this frame. You can see the buildings in there as a collision as well. You can see these are the layers of the building. So I ran this after the stream last week, and it took quite a while because it's pretty heavy simulation. I wasn't terribly thrilled with it, it wasn't amazing. And it also sort of, because it took so long to do this high resolution simulation, I was kind of like, no, it sort of defeats the purpose of me simplifying this whole shot. So it kind of didn't sit well with me that I had created this nice procedural wave and then gone and added, a really high resolution simulation, which took, I don't know, a couple of hours. Let's have a look. The way that I check to see how long a sim has taken, if I've done it and I can't remember, is to just open up the BGO files and have a look at when the first frame started. So 2:40 PM, you can see, to 7 PM. So it took, four and a bit hours to simulate 90 frames. So it's not bad, it's not unheard of, but it's not fast, that's for sure. So, I kind of didn't love the fact that it was so slow. I did run it through and had a look at kind of what that was looking like as particle fluid surface. So what did I do here? I created a group from the inside wave. So I have this object here, which is like the inside of the wave curl. And if I use that to create a group, I can group everything that's inside that space so that everything outside can be deleted, which just simplifies things for meshing. And then I run that into a particle fluid surface. And particle fluids worfus, it says. I must have accidentally hit W. You can also see at this resolution of particles, it's quite slow to mesh as well. So that's another consideration, that a higher resolution simulation is also going to take a lot longer to surface. The surface will look pretty cool, but yeah, it's it's something that you need to think about as well. It's not just the simulation time, it's then the subsequent meshing time. So I would be caching this mesh to disk as well after I'd kind of settled on a resolution that worked. So we should see now. Let's have a look. There we go. So there's some cool details in there, it's a pretty nice splashy fluidy thing. I mean, it might kind of work fine, this element. It's not meant to be the main sort of element, it's just meant to be an sort of edge element to the ground. If we combine, let's see, this is the wave, I think. Combine the wave in there, then you can see all those kind of elements a little clearer. And then I also added a pop net here. Let's see what I was doing with that. So in this attribute wrangle here, I'm actually just calculating the speed of the particles. Hey, Hardik, how's it going? Good to see you. How's your showreel going? Have you finished it off? So Yeah, I'm calculating the speed of the particles, because particles have, coming out of flip, they have the v attribute, which is the velocity. So if you do a length from that velocity, you're going to get the speed, magnitude at how fast those particles are moving, or the length of the vector. So by fitting that into color, what I can do is basically represent that speed as a color. And I've created two channels here, Vmin and Vmax. So I can basically say, I want to sample the speed value that I'm creating here, length v at v. I want to sample it between a minimum speed and a maximum speed. So as I change this, you'll see, like if I just do 0 to 8.1, you'll see I get a kind of gradient from black to white. But as I clip that, as I raise this value, it will give me more black, because it's refitting these values to between 0 and 1. So what is 5 now becomes 0 in terms of color, which is black. So all of those things, all those particles, all those flip points that are going less than 5 in magnitude of speed, or magnitude of velocity, are now just being represented as black. So I think I clipped it pretty tight like this, 7 to 8.1. And then I can see, I just get those particles that are really flying out, showing up as white. And what I can do is isolate those. So I blast that, and then I end up with that kind of thing, which I'm running into a popnet. So let's have a look at that. I'm not sure if this worked exactly. I may have just abandoned it, but let's have a look and see what it yields. Hey Rizwan, how's it going? You're still working on your show reel. How's it going, Hadik? You were saying that building destruction is complicated, and I think it is. You know, it is a complex kind of area to just dive into as a beginner. You know, there's a lot of things to consider. And I have covered some destruction stuff in the past, and we did some with this wave, just a simple building kind of knocking over. But we can certainly, that's something that we can look at in the future as well, is you know, just how to set up a building destruction. I'll add that to the list. How's the weather in Australia? It is cold, as you can tell. I'm wearing a beanie. It is cold here. It's winter now, so it's let me tell you, it's not too bad. It's 14 degrees Celsius today, or right now, but it gets down to about 4 or something. 4 degrees overnight. So yeah, it's pretty cold. Not always sunny and warm here. So this popnet, you can see, is just kind of generating just a cloud of particles basically, and that can just be useful for a spray element, because our particle fluid surface is sort of yielding like the fluid, but this could be a spray. It's somewhere over here. Where are you, Rizwan? Sorry, do you remind me again where you are? So I was doing something else here. I thought what I would try, it didn't quite work, but I'll show you anyway. What I sort of thought might be cool is if this fluid was more like a churning foam look. So less of a fluid look to it, more of a sort of foamy look. So I'm not sure, I can't really remember why I did the volume rasterize and the particle fluid surface here. United States. Makes sense. Yeah, it's opposite. When it's winter here, it's summer there. How hot is it in Alabama at the moment? I guess it's nighttime, right? But so what I have done here, let's see. Convert to mesh, convert to fog. Particle fluid surface. I guess I flipped this. What I had done here, I don't know why I merged them together, I'm not really sure why I did that, but what I had done here was just output this as a surface VDB, then convert it from an SDF to a fog, which generates the fog, and then the name renames surface to density. So that I guess, gives me a fog volume as well. I think I just ended up going with this one because it was faster. The volume rasterize attributes is a little bit easier, which is why I also created this density attribute here. So that's why that is there on that ramp. 73 degrees. I don't know what that is. Let me look it up. 73 Fahrenheit Celsius. 22. Oh, that's pretty nice. Not too hot. So yeah, the volume rasterize attributes gives you a bit more control when you're just turning particles into a volume, so that's a pretty good one to use. And the particle fluid surface can be slow, so you know, it's just trying to find the fastest one. So what I thought would be cool is to, if I go further along here, let's go to like 57. The other thing I found with this is that it kind of looks, you know, it looks good from kind of here. You know, if you're on the side, it looks kind of cool. But if you're looking through our camera, which is very far away from our camera, it actually, you know, it doesn't kind of work as well. But, so we could, you know, we could try moving the camera, although that may throw other things out. But let's have a look. So if I jump out of here, and I think I did set up a little render for it, so you can see it there. There's our foamy stuff. So wave base, classic shader 2. Let's see, where's classic shader 2? There it is. So I duplicated the shader that we had. So I copied the classic shader that was on the wave, and you can see here I've actually brought in vorticity, but I think the first time that I ran this simulation I didn't have vorticity. Let's have a look at that. Oh, I do. I turned it on. That's good. Okay, that's cool. So vorticity, if we have a look through a color node, is going to show me the change of direction. So it's kind of like shows the curl of the particles. So you can put it in a color node, and good to check on the geometry spreadsheet. Hide all vorticity. Yeah, I always, when I say 73 degrees, I'm like, that's not in Celsius, no way. It does get hot in Australia, but not that hot. So you can see vorticity, it's going up to 10,000. So I'll adjust my range here to 0 to 10,000 for starters. And those 10,000 particles are probably just some random ones that are getting some crazy high values. You can see them here, they're the white ones. So if we drop this down, let's drop it down to 1,000, then we can see a bit more coming through. There's still a lot of these that aren't, they're all black. So let's take it down to 100. There we go, that range looks a little better. So, and we can up the minimum so that we can kind of compress and contrast this range so that we can really dial it in so that we get just the sort of high vorticity areas. Well, we're just trying to figure out what sort of range it is. There's something crazy happening here. I think probably that's where the building collision is happening. So the particle hits the building and it changes direction immediately, so it registers a very high vorticity value. So that's probably what's going on there. So we can use those attributes in the shader to drive certain things. So I think I changed this. I think that's probably why I had this flicked back to surface polygons, is I was probably rendering this with the classic shader on as a mesh to see kind of what that looked like. So let's have a look and see what it looks like. But yeah, the fluid density, VDB particle fluid density calculation is really, really slow. So it's, yeah, just going to have to wait, unfortunately. There we go. Alright, we've got a lot of stuff back here as well, which, you know, probably we don't need, which we could clip out, but that's alright. Some cool details in there. Let's have a look. Camera 5. Okay, so we've got our wave base. Let's have a look at our shader again. So I'm bringing that vorticity attribute in off the mesh, and I think, let me just double check, I've added it here. So transfer attributes of vorticity. Oh, and I've also added that V speed there. So I've created that one there. So just any attributes that you create, you might need to add them in if you want them to transfer to the mesh. So we should see, there it is there, exists on the mesh. And if I plug that color into the mesh as well, we should see that similar variation in tone. There we go. So you might be able to guess what I'm going to do with this. I can kind of use that to derive shader colors. So what I usually do with vorticity and shader colors is I will go from a blue color for the water, or blue-green, to a white for the foam. So anywhere where there might be high vorticity, I'm going to render that as foam. So it kind of looks like, it looks like bubbles, it looks like foam in the ocean, and a bit of churn. And you can adjust this ramp to dial that in. So the lower you go with that minimum, the more of that white will sort of come in and the less of the blue you'll get. So you can really play with it and make it, very sort of customized effect. And you can add more colors to the ramp as well. So you got sort of a dark color, then a lighter color, and then white. Do something like that. You can start to see it. It actually looks, it starts to look quite cool, even just in the viewport. You could also blur the colors after that if you wanted to, or you could even attribute blur the vorticity attribute. So I'll put vorticity in there. Let's have a look. You can see how that starts to smooth things out. So if I go through, let's put the blurring iterations up a bit, 5, 10, and you can see how that smooths out that effect. So it's no longer a bit jagged in some of those areas because it exists on every point. It's changing on every point. So if you blur it out, that's just going to give you a much smoother result. And you would want to do that before you jump into your shader. So we would want to render it from this point here, because we don't have the ability to blur it in the material. There's no attribute blur in here. So now we're just bringing that blurred vorticity in. So that might work better. I didn't do that before, but I think that might work cool. Here's our values, 30 to 120. So we can put those in the color and just visualize what that looks like as well. 30 to 120. May need to change it a little bit, but I think it looks pretty cool. I think we could probably bring in a bit more white. So we could bring down the ramp, or we could bring down our high value. So something like that. Oops. Let's try something like that. I'll set my render flag on the attribute blur. Go to my material, so you see running it through a fit and then running it through a series of ramps, and they're getting plugged into different things. So the first one here is refract color, and this is actually a kind of dirty color. Have a look at this one. This is going into refraction intensity. So what this is saying is that when the vorticity is lower, the refraction intensity is white, so that means it's fully refractive. But as the vorticity goes up, I'm pushing it towards this grey colour, 0.175, so it's pretty low, almost towards 0. And that will change the way that it refracts. It will drop the refraction so that it refracts less the higher vorticity it goes. I have another ramp here, which is being plugged into emission colour. And that means that when the vorticity is low, there's no emission, and when the vorticity is high, it's going to have white emission. So let's have a look and see kind of what this is going to end up looking like. So we'll go to the out. I've got this wave base test set up. Wave base, we've got all our holdouts in there. Let's just go and have a look and see what it looks like. Render view, camera 5, wave base test, render. Hopefully my settings aren't too bad. I can't remember whether I did this at high quality or low quality. Probably low. Oh, it's, yeah, pixel samples 3. It might be a bit slow. Let's have a look. No, it's pretty quick. It's a surface, so it's not a volume, so it is going to render, hopefully, reasonably fast. But we could take pixel samples down as well. There we go. It's a bit noisy, but at least we can see it. We've got motion blur on as well. Might turn that off, and then we can see the mesh a little clearer and what it's kind of doing with the coloration and that sort of stuff. Let's have a look. So it's a little bit hard to see what's going on, but basically what we can kind of see here is that here's our color ramp, which is driving our refraction base color. And you can see that these, we sort of know that these were the areas of low vorticity, and they're sort of getting this darker browny color. And the areas of high vorticity are getting this light color, which is turning it into looking a bit like foam. So if we come over to where that building interaction was, it actually might be obscured by the holdout, but we should see around there like quite a bit of that white. And we can play with this ramp as well to, to force those areas to be whiter. So let's render this out. So it's a really good way of getting a foamy kind of variation. I might make this half res, that'll render a lot faster again. It's a really good way of creating foamy variation without actually having to do a whitewater simulation. And it's handy to have a whitewater simulation on top so that you have that element as well. But this is a really good way of like creating that supporting material underneath that's part of the water, and it just feels more integrated. You can see these bits that really look like they're glowing. They're the bits that have that high emission value. So if we take our emission down, let's click on the shader, go to emission. We've got this emission intensity. The color is being overridden by our ramp, which is this one. That's our emission intensity there. But rather than changing that color on the ramp, I can just drop this down and we'll see those will reduce. There you go. So you can see now they're not so bright. Maybe 0.5, something like that. And that emission is just there to make them sort of feel like they're, bubbles. They tend not to shadow and they tend to transmit light and be quite bright. So it's just to try and make it look more like foam and like bubbles are. So let's change this fit and see what happens. So we'll bring this down. Let's bring it down to 80. And you can see there we get much more sort of white foamy look. So I made it this kind of dirty color because it's water that's on the ground and it's churning up. And when you look at, real footage of tsunamis, the water that is kind of washing over the land is just super dirty because it's picking up all of that dirt and debris and everything. So it looks very, very brown. Even the color, the color of the foam, I haven't gone for perfect white, and I could make it sort of more yellowy to give it that kind of, really dirty foam look. Maybe the emission color is overriding that, so we might need to just make that actually look a bit kind of foamy and dirty, or dirty as well, dirty sort of foam look. So you can see there, it's just taking the white out of it. It just makes it feel a bit kind of, a bit kind of grosser. But I think that works well. So let's have a look. I don't know if the illumination will have any effect. Emission illuminates objects. I don't know if that'll change anything. Let's see. It did kind of dull it down a bit. So yeah, maybe have that turned off. That might sort of help. I think I want it to be a little bit brighter. Maybe with the emission turned off, it won't be as crazy bright. There we go. So I think that, it kind of works well. It's a really good way of creating that sort of look, that mix of really refractive stuff and really foamy stuff. You can see if I adjust our refraction intensity ramp here, so this is this one, I can make this all kind of refractive. If I get rid of that, it will make everything more refractive. These parts will still look white, but these sort of intermediate parts will be, just completely refractive now. It's a subtle change, but I feel like having that slightly less refractivity in the foam area just makes it feel a bit denser and a bit more kind of foggy and foamy feeling. It's hard to see, at half res and at this resolution, at this distance from camera, you can't really see that subtlety that well. But when I've done this in the past, I do find that it does help. It's really kind of a nice way to make that foam feel a bit more realistic. So let's have a look. You can definitely see a change, but it is subtle. And then, yeah, that's our emission, and then our color. So our color, we could change that if I copy this ramp, so I retain it. This could be blue. It doesn't have to be the sort of browny color. If you wanted it to be more of a traditional water color, you could make it blue. You make it a bluey green. There you go. Maybe a little more turquoise. There you go. So that's more your kind of traditional watercolors, and it actually works pretty well. That blue and white, it does look quite watery, which is cool. Let's drop this down. Let's go to 10 to 100 and see what that gives us. Might give us a greater kind of range of variation from the blue to the white. So I really like doing this with fluid shaders. It gives you, a lot more sort of variation and interesting, realistic changes to the fluid. Instead of just slapping a refractive shader on everything and just hoping for the best, using the attributes that are present on the mesh that you've created, whether it's like the speed or whether it's the existing attributes, it's a really good way to create some really nice variation. This is getting pretty bright over here, and I think that's just down to the lights in that area. This area here is under shadow, but this area is getting light from the spotlight coming in, so it's a little bit hotter over there. Anyway, that I think is an interesting way of approaching it. The other thing that I was trying with this was to render it as a fog, so as a volume. So if I snapshot this, save that one, go back to my fog here. So there's my volume rasterize attributes. If I then go to my materials, and I think I created, let's have a look, foam. Do I have one here? Dirty foam, there we go. So it's very similar to this foam shader that I made with a pyro shader core or a volume shader core. Let's have a look. There we go, pyro shader core. And what I did here was I brought in the density attribute, so just using bind. And then I created two colors, so a kind of dirty color and a white color. Again, it's a similar kind of principle. Then I'm multiplying those colors. So those colors are mixing based on the density. So their bias is when the density is higher, it will switch to the input 2. And when the density is lower, it will switch to input 1. I'm running those into a multiply, so multiplying those colors by the density again, and then an overall multiplier, which is out on the outside. You can see that's multiplied up to 100. That is being plugged into density, but the crucial thing here is that the signature of the density is set to vector density. So vector density actually changes the color, sort of, it gets that light scattering effect where you get different colors depending on the density of the smoke. So by feeding in colors into the density slot, which you don't usually do, usually you would just plug a color into the smoke color maybe, you will get these different colors coming through, which is a really nice effect. So that is then going through a compute lighting, and let's apply that to this object and have a look, see what that looks like. I really like this technique of shading for shading smoke as well. It gives you a kind of almost a subsurface kind of look when you're rendering volumes. And there we go, we get nothing, which is great. So let's have a look. Wave base. Oh, my render flag is all the way up here on our mesh. Let's control click on there. Hopefully we get something this time. Hey, there we go. All right, so we're getting something. Without motion blur, the volume here looks a bit kind of weird. Let's have a look at this one. This volume isn't looking that great at the moment. Let's have a look at creating it this way. So I'm just going to pause this for a second. Output surface VDB, convert that SDF to a fog, and then change the name to density. Let's have a look at that and see if that one looks a little bit better. Well, the volume feels a little bit better, but the shading is still kind of a bit ordinary. So let's have a look at the material. Oops. Dirty foam. We've got our density, we've got our colors. We have shadow density of 1. Let's have a look at the lights that we have here. So we've got our environment light. Shadows of 0.99, we've got our spotlight, shadows of 1, spotlight 2, shadows of 0.85. I'm just going to put that up to, or let me check the lights that I have in here. Spotlight 2 and environment light 1. So let me go and go spotlight 2. Let's set this back to 0.99. And you can see how like those areas there, those ones that are looking very flat in our first render, they should be completely in shadow. That's why they're looking a bit weird, I think. So that shadow is kind of quite important. But I do like to have shadows that are under 1, just to give a little bit of luminosity to things. Because I never really render with diffuse bounces as well, GI, in Mantra, because it's so slow and noisy. I never use this. So by taking a little value off the shadow intensity, I never get solid black shadows. I get just a little bit of color information. Even if you did 0.999, you know, that will sort of just lift the shadows a little bit. The light is strong. I think probably what I've done is lifted this up for the mesh, and I probably do need to drop it down a little bit for the volume. So you can see there that just takes that kind of that really intense brightness out of it. You try turning off the environment light as well for this and see kind of what that looks like. Looks like it did nothing. Objects, environment light 1. We are forcing it, but oh, there we go. Take it out of the force slot. Now we can see it. And you can see how much faster it renders as well. Like, environment lights really are a killer for volumes, so, you know, maybe it's good to leave it off. I don't love this kind of shadow that we're getting, but we could, for the purposes of testing, we could take these things out of the render and you will see a great deal more. And you can start to see that kind of subsurface look that I was going for. So it doesn't really work with the shadows coming from the objects, but you can see this, you can start to see this color coming through here. So let's maybe jump forward a little bit. Let's go to 68. See if we can see it a bit better. I think this is why I kind of abandoned this concept. I had it looking really good from a different camera angle. I was just testing and it looked really cool. And I was like, all right, cool. Let's have a look through our camera. And it didn't really work as well. So I think that's why I abandoned this, this fog volume that I was looking at, because it just didn't seem to work as well through the camera. Let's go. Actually, you know what? Let's find a. I'll show you, kind of how it looks good, and then we can just forget about it because it really doesn't work from this camera angle. Let me just set a camera here, new camera, and I'll have a look at it through that camera. Which is ridiculous because, we're working to our camera, so it's silly to do this, but just to kind of show you how, nice these fog kind of volumes can look. Let's turn off half res and we'll play with this a little bit. Hey TK, how's it going? Thanks for joining me. So you'll see as I kind of increase the saturation of this, maybe make it slightly more. Well, there we go. So, I mean, that's unrealistic, but what you get is this really interesting light scattering effect coming through. And I think that it can look really, really nice. Gives you a really kind of interesting scattering look. And in this instance, it doesn't really work for our camera. Probably my density is too high, which is stopping a lot of that. Hey, so this is TK from YouTube. I don't understand what that means, but thank you for joining me. So let's have a look. Material. Let's take this back down, that saturation. There we go. So it's starting to kind of look a bit more interesting now. So as you take the saturation down, obviously it lessens that effect, but in reality, we don't want it to be overly saturated. So there we go. So it's a really nice way of adding like an extra detail. Whereas if you just go density into, let's get rid of the color for a second. You've been wanting to learn VFX in Houdini. Oh, is this TK as well? The Fallen 147. Yeah, VFX in Houdini is amazing, and you should learn it. It's great. It's a lot of fun. Takes a while to learn, but it is the things that you can make once you okay, I get it now. The things that you can make are incredible. You're only limited by your own imagination, and that's what's really fun. So you can see there's just my regular old smoke color, and it feels a bit kind of flat and monochromatic and just not very interesting. But when you add in this color into the mix, it just gives it a bit of life and a bit of kind of, I don't know, yeah, this really nice kind of subsurface feeling. You got to get the colors right, which can be a little bit challenging because as they scatter, they actually don't give you the color that you put in. So if you push it too far, the scattering, like if you push the saturation too far, it will actually output the opposite color on the color spectrum. So you can see I'm starting to get blue in here. I'm also getting this red, but what it's doing as I saturate it is it's actually inverting as it scatters, and it's coming over to blue on the opposite side of the color wheel. So that is a cool effect as well, but it's something that you need to be aware of. So I try and keep the saturation low. But I think like for a dirty kind of foamy ocean, I think it's happening in Turkey or somewhere at the moment. They call it sea snot, where you get this like gross dirty foam on the ocean. You would have seen it if you've ever been to the ocean. You occasionally get this like this really foamy stuff on the surface of the ocean, and it looks kind of yellowy and dirty and gross. So I thought that this was a really cool look for that type of, yeah, that weird foam, that weird foam that looks like somebody poured a whole bottle of dishwashing liquid into the sea. Yeah, that's right. It's kind of slimy. Sometimes it's not super slimy. Sometimes it's just super foamy and it just kind of washes up onto the beach. But yeah, I thought this was a really nice look for that. I think the quality of this could be a little better, the resolution of the volume. But as you can see, when I switch cameras, it kind of doesn't work as well. So I sort of thought, nah, maybe not, for this one. I don't know. Maybe it is good. Have to render it out and see. One of the issues is as these particles fly forwards into the camera, they actually get quite big and low resolution. So maybe need to come up with some solution for that. It's actually looking a bit better now after dialing in those colors a little more. It's actually looking a little bit nicer. So anyway, that's kind of, I think, a good way to treat that foam stuff. As you can see, though, when I add back in my objects, so like, where's all my objects again? If I add into my matte slot, my let's see, wave and buildings, mid-ground buildings, maybe BG buildings. Can't remember which buildings are which. I think it's those ones. If I add those back in, hey Zoe, render lifestyle makes me uncomfortable. What do you mean? What do you mean? Like waiting? So yeah, as you can see, the shadows they do kind of ruin it a little bit. So you could set up a completely custom lighting environment. Yeah, the waiting game. That's right. Well, I'm gonna jump into Redshift and have a look at how we could set this up in a faster way. Hopefully, I mean, there are some limitations with Redshift, and it can be a little challenging sometimes, but it can be a really good option for creating quite a fast setup. So one thing that you could do with this foam is to take the shadow density down, although it doesn't really seem to be changing a great deal. Sometimes with this interactive renderer, it's not super interactive, and if you see something like that where it's not changing, stop it and hit render again, just to make sure. So it's going to recalculate, but then hopefully I'll see this change, because it should. Yeah, it's not. Well, that's great. Why isn't it? I don't know. Maybe it's because of the vector density that it's not changing. I'm not sure. Let's go and have a look at our lights again. So we've got Spotlight 2. The shadow density, we already looked at that. So we could just take that up again. And there you go. We get our kind of lightness. You could set up custom lights as well for this particular pass, just so it looks good. is that VOPs as well? Is what VOPs? The materials? Yeah, materials are VOPs. So the entire materials kind of context is VOP based. So you can see out here even I'm doing VOP stuff in these materials. So once you learn VOPs, you basically can, you know, take all of that information into materials. And that's great. I really like working this way with materials. It's very flexible. And things that you do in VOPs as well, you can copy out and paste them into materials. You don't like VOPs, is that? I really like VOPs. Hey David, how's it going? Thanks for joining me. I really like VOPs. I think, you know, they're visual, and that's where I'm at. You know, I'm more of a visual person than a code person, whatever that sort of person is. Technical, I guess. So I really like the visual way of working in VOPs. But you know, each kind of part of working in Houdini has its pros and cons. So yeah, you just use what is appropriate and what you're comfortable with. So I have this file open in Houdini 18, which is where my Redshift lies. And let's start having a look. Hopefully it'll work. I don't think there's anything too Houdini 18.5 specific in here that won't work, but let's start by just setting up our environment for starters and our lighting. So the thing with Redshift is that you can't use Houdini lights and you can't use Houdini materials. So we need to create all these things again. So we've got our wave, we've got our BG buildings and our mid-ground building, ground plane. The other thing to be aware of with Redshift is that it doesn't use packed geometry, so you need to unpack things. There are ways of setting up instances and stuff like that, but usually I'll just make sure that I'm not packing or using any Houdini primitives as well. It doesn't like those. So I'm going to just delete my environment light here. Have a look at my spotlight too, just the position of it. So I'm kind of going from this direction here. So I'm going to set up a similar light orientation. So just looking like this. I've got my Redshift tab up here and I've got my RS light. If I control click, it'll drop on down roughly in the same area. So there's my first Redshift light. And I'm not using Spotlight 1, so I'll get rid of that. And let's go and set up a Redshift ROP. So Redshift render. Give it a shot. Otherwise, post it in the comments afterwards, David. But yeah, I'd like to see it. Let's see. So we've got our Redshift ROP here, and I'm going to choose camera 5. That's the one we've been working with. Go to my objects. You can see a lot of these things are very similar to Mantra. So we've got our objects here. I'm just going to first bring in foreground buildings, BG buildings, and ground plane. And all of these things that's cool. Mine is a little bit over the top, I must say. So all of these things, actually the ground plane doesn't have a material. The BG buildings and the MG buildings have this building material. So I'm going to go and, what am I going to do? I'm going to put a new one down, RS material. And this can just be my sort of default shader. And I'm just going to apply that to all of these guys. So /map/default. There it is. Okie dokie. Let's go to the out context. Redshift ROP candidate lights is RS light. That's okay. Let's open render view. Select ROP, Redshift ROP, and it should start. Well, as long as you did exactly what they asked for, that's the main thing. Sometimes it's not quite as fun, but you know, got to get paid, got to do what the client wants. I don't see a link if you did post one, but yeah, if it, you know, if you can post it in the comments, I'd love to see it. All right, so here's our render. It's looking good. It's a bit too dark. I'm just going to put that there, and let's go to our light. Got our intensity multiplier, which is quite high, and our exposure. So let's up our exposure. And you can see, this is just updating, you know, live. So you can see how quickly it's rendering. There's our other buildings coming in. So I guess it looks like we've got a spotlight behavior going on, or maybe the size of our area light. Maybe let's make it a distant light. Might work well. You can see we've got just perfectly reflective objects here, which looks kind of cool, but let's go to the material. Yeah, this is really quick. I mean, you do have to have a decent graphics card to run, or a half decent graphics card to run Redshift. So there we go. There's the reflections taken off. So now we can see what that light's doing. Let's add an RS dome light. Ah, there we go. Look at that. Almost instant. So what did we have? I deleted my environment light, but I do have it. Here's one I prepared earlier. I do have it in this other file, so I just want to see what HDR I'm using here. I'm going to grab this. I'm going to stop this render. Oops, where is it? There, stop that. Don't need them both rendering. Okay, and RS dome lights, they don't use, so if you go to the light dome map and it takes you to this Houdini HDRI, they don't use these RAT files, so you have to use a proper HDRI, which you can grab from HDRI Haven, which is a good website. MacBook Pro 2014, yeah, that's right. that will be my next series. So Houdini with Poop Laptop 101. Yeah, I can't see the link, David. Just have to post it in the comments, I guess. So yeah, this probably won't. Redshift probably won't work on your MacBook Pro. I'd say almost certainly it won't work on your MacBook Pro. But you know, one day when you upgrade, it's good to think about, you know, the graphics card and to check whether it will work with, you know, with GPU renderers like this, because they are significantly faster, and it does make doing things like this a lot more feasible. So let's go to our material now, and I'll make this a kind of, I don't know, slightly saturated browny yellow color. This is not updating anymore. There we go. Oh, look at that. We've got a sky as well. Doesn't that look nice? Cool. Okay, so look at this building over here. This is not showing up. We've got BG buildings. I think that's that one. It's got the shader, but it is not showing up. So let's have a look. Aurelia Awakens. Oh, cool. Okay, so here's our purple render flag down here. And we've also got building destruction here as well. But let's check out these. So we've got polygons. Yeah, I mean, that should be right. There may be some other weird things going on. BG buildings. I've got our view flag up here. Maybe we should render from our view flag instead. Perhaps it's off our camera. Let's check out our camera. Redshift drop. Maybe I have the wrong thing selected. BG buildings. Mid-ground buildings. Ah. Oh, it's the mid-ground building. That's the problem. Okay. It's got a shot material path on it, so that could be the problem. So that is pointing to a material that is not the Redshift material. So that could be the issue here. Let's open this back up. Attribute delete. No worries. It will make sense eventually. Don't worry. Set my render flag there. Mid-ground buildings, BG buildings. Alright, let's try again. You would have to check on your graphics card, Hardik. So it's all about the graphics card capability. And I believe you need a minimum of 8 gig VRAM on your graphics card. But if you just look up like your graphics card and Redshift compatibility, then that that will show you what you need. So this is not showing up, this MG building. Let's see, have I even added it? No, I haven't. What a fool. Foreground buildings instead. Oops. There we go, MG building. Let's try that one. Hey, there it is. You can see it's showing up black as well, and I noticed that in the viewport, and the normals look a bit flipped or something, so let's put a reverse down. Let's see if that fixes it. No, it doesn't. Oh, render flag. There we go. So it wasn't the normals really, but it was the polygons were flipped. Usually happens when you do import stuff from Maya, so when you see them show up like this, like blue in the viewport, or black even, then the polygons are potentially flipped. Yeah, I mean, you'll have to look it up, Hardik. I don't really know, but it sounds to me if it's only a 4 gigabyte graphics card, it probably will not work. I couldn't get it to work on my laptop. Are there any Redshift presets? Hey, Carlos. Yes, there are. So if you go to the Redshift material, it does have a bunch of presets, so you can create things like plastic, water, iron, all that sort of stuff. So there are those, but that's it. As far as I'm aware, that's the only kind of presets that you have. So yeah, I mean, it is a good place to start. If you wanted to create metal, for example, I might create that and just see what their kind of settings are. If you wanted to make these look like paper, you could do that. Or of course you can make your custom shader. So I'm gonna take this back down. What did I just do? Undo all that. There we go. So I think my light is probably a bit strong, this RS light. Exposure. RS dome light. Let's have a look at that. This one. Oh, there we go. Let's try spotlight. Area light. Spot. Some crazy shadows here from something. Not sure what that's about. Okay, that's kind of, it's getting there. This one I'm going to make a little bit yellow. So it's always good to give your lights and materials a bit of color, so that not everything is just kind of flat and desaturated. That's often the problem with a lot of 3D stuff, is that it's all kind of lifeless, because lights by default are always white, and materials don't have a lot of variation and things like that. So it does really help to kind of just give things color and and try and make them just feel a little bit more interesting. Same with the smoke, you know, adding that sort of, adding that color to the density just really transforms it into something a bit more interesting. So adding a little bit of reflection and roughness. Let's add our wave in now. So we've got the wave, go out. So we should see that show up. We need to give this a material as well. So let's go back to our material context. We can just duplicate the default one, apply it to the wave. There it is, nice grey wave. And let's go now, and you get this bug with Redshift. I don't know if anyone's seen it when they use it, but my color palette just progressively moves off screen to the point where I've lost the X to close it. So you have to do this thing, which is Alt space M to get the Windows move function, and then you can arrow down to get it back and then close it. It's really annoying. If I do it again, it just, every time I open it, it gets slightly higher in my UI. See that? It's just going up every so often, and eventually it will go off the screen. It's very frustrating. But if you move it down, you can kind of get away with it. So, I don't know, let's see, what am I going to do? Maybe I'll just have a look at water, see what that looks like. Hey, Robert, how's it going? You made it. So there's a water shader, you know, very quick, just a simple kind of refractive shader. Let's have a look at around 40, see what that looks like. Boom, that looks cool. There you go, very simple, easy to create water shader, but it's not the water shader that we want. So let's have a look at what we were doing with our shader here. Here's our classic shader for the water. We had no diffuse color, we had reflection with no roughness, and we had refraction with color being overridden. You can see that that's grayed out, so that tells me that something's plugged in there. There's no roughness, and I have this faux caustics turned on, which I don't know if I have the ability to do with Redshift. So we've got things plugged into the refraction base color and the refraction intensity. And what is driving that is this little setup here, which is basically just giving me different colors based on the height. So what I've done here is taken the P position of my wave. I'm running it through a transform, which takes it from world space, where the position is in world space, to the render space. Because when you take a P position, in render space, X and Y are not the same as what they are in world space, so you need to transform them to the space that you're working in. Or transform them back, actually, is what's going on here, is that we're taking the P that relates to the render space, so X, Y is up, X is across, and Z is depth, and we're transforming it back into object space, so that when we sample the position of our wave, we get the correct height relative to the wave in world space, not render space, if that makes sense. A little bit confusing. So what I'm doing is basically taking the Y component of the position of the wave, and I'm running that through a ramp. I think I jumped out into my viewport and looked at how high it was, decided on 4.3, and then I run that through a ramp. So what this ramp is doing is blue at the bottom of the wave, green, light blue, and then finally, you know, approaching white towards the very top. So I can do the same thing with Redshift, but I need to do it slightly differently. So let's have a look at our wave. We'll open up our properties, and we've got diffuse here is set to 0. So this is the water preset that we put on. So diffuse is set to 0, which is good. I'm just going to set that color to black. The reflection is 1, roughness is 0. That's all good. Here's our refraction, so that's going to drive how transparent the wave is. And we've got some dispersion here, which is actually adding, you can see when it starts rendering, if I put that up, this kind of rainbow effect that's going on there, and that will introduce a little coloration into the wave. So I'm actually going to turn that off. I don't want that. And all right, so here's our refraction color and refraction weight. So color and weight. Let's see what happens if I change the color. Goes yellow. Great. So refraction color. Now we have our global variables, which should still work with Redshift. I think, maybe not actually. This is the kind of annoying part when you're building shaders in Redshift, is that you can't use all of the same things that you could with Mantra. So it becomes slightly challenging to figure out what those nodes are called and which one, which one is the one that you need. For example, a fit is called RS change range. Go figure. They could have called it RS fit, but they didn't. So we also have RS ramp, and that's our color ramp. We can plug an input into there. So there's our fit into the input of the ramp, and here's where we can do our coloration. Now, handily, I should be able to, I think. Let's see, copy from there. Oops, where are we? Down here. Paste values. Great. So let's see if we can do an RS vector. Now this is one that I can't remember which one. Let's see, vector to scalar. I think that's the one. There we go. So we'll take our P position. We'll try and do our transform here. Not that one. Top one. There we go. Try and do that and see if it works. Don't know if it will. Into the input. Our old range was 4.3. That's what we had previously. Running into our ramp. And then our ramp goes into refraction color. Okay, so that looks to me like it's not working. Let's try changing this value. So I suspect what's going on there is that it's just not grabbing the P value, which I kind of thought maybe that would happen. So let's go and grab RS point attribute and set the attribute name to P. Plug that into our vector to scalars and see if that updates. And it does not. Fraction color, let's make sure we plugged into the right one. Yes. Okay, so what have we got here? RS. Let's have a look through all of the different things that we have available to us. I wonder if there's something called RS globals. No. RS vector. Maker. RS vector user data. So what that is. P. RS vector to scalar. Y. Texture space. UV. It's not really what I want to do texture space on, but I don't know if that matters, that one. So this is the challenge with Redshift is figuring this stuff out. And I thought that might work, but it doesn't really seem to be. It is a good idea just to stop it and double check that it's not the interactive thing not working, but looks like it's still just giving me blue. Now, another thing that I can do here, which is probably what I would do now at this point. I mean, maybe I would Google and try and figure it out. But another thing that I do like doing, which gives me a little bit more control. It's not perfect because it's point-based, so you're limited to the resolution of your mesh. But this wave does have a lot of points, so it actually probably will be okay. What I might do here is I will put an attribute wrangle down, or I could do it in a VOP, and say v at height equals fit v at p Oh, actually not height. I'm just going to do F. Sorry, not V, F. So I'm going to do fit P dot Y between 0 and 0.43. Oh, sorry, 4.3. 0 to 1. So that is going to give me a height value. If I visualize it through color, that is going to give me a ramp from black to white for the height. And I can use that instead of trying to do that calculation in Redshift materials. So instead of this whole thing now, I should just be able to do particle attribute lookup, or actually RS point attribute, or RS user data. Maybe that one would work for P, I don't know. There's RS user scalar user data or particle attribute lookup. I think either one of those you can use. So let's try this one first. Bring in that height, run it into the ramp, and it's a scalar. So let's see if that works. Hey, there you go. So that's usually what I end up doing when I can't figure it out. I will set it on the geometry because I know at least that this method works, where you can set it on the geometry and bring it in. So it's a little bit simpler as well. And it means that you can do some of those steps with your already kind of known processes with Houdini nodes. So there we go. It's a bit simpler. Let's have a look at the next component. So we've got a ramp. This ramp, let's do it. Again, we'll copy that. We'll duplicate that ramp and paste those values. And that one's going into refraction intensity. So that would be refraction weight. And you can see how that actually, it sort of makes it a bit more foggy. So it's sort of a bit fogged up the top. It's not super transparent. So I don't know. It's an interesting thing to try. The reflection on this is a bit crazy. Let's have a look at what we had originally. So I had 1 on here, but it seems maybe a little bit intense. So you could always turn it down, you know. Sometimes it's always a tendency to make things fully reflective, but sometimes it doesn't actually look that great fully reflective. So you may want to turn that down. It's a little bit better. So let's see, what else do we have here? We've got all our sprays. We've got our wave base that we added in, so we can turn that on. And let's see, what have we got? We've got a particle fluid surface. We could try the volume technique. Let's have a look at this particle fluid surface here. You're gonna have to wait for it to calculate. Yeah, I mean, this is a good thing about Redshift is that, yeah, if you can get it to work, that it allows you to kind of develop up your look and your shaders and your lighting very quickly. And that's important when when you want to do these things and work efficiently and set up really good lighting, is that ability to kind of iterate and just look dev things very quickly is really valuable. Whereas if every time you render, it takes you 10 minutes or 5 minutes or 2 minutes or 1 minute even, that process becomes very slow and very kind of grating, and you maybe don't spend as long working on shaders just because of how long it takes to look dev stuff. So I think this phase of any project is really, really important, and I will spend, an entire day, if not 2, just working on shaders and, look and lighting and all that stuff. Doing the destruction and doing your effects is one thing, but if you can't make it look good at the end of the day, it just, it just sort of, it betrays your, your time, and it's sort of, you're wasting your time, because you've spent all this time creating a really nice effect, but then you kind of you can't present it in a way that makes it look as good as, you know, how it looks in the viewport. So it is a really important step to kind of look at. All right, so there's our crazy mesh. Let's have a look at this with a Redshift shader on it. So I will just duplicate this material. I'm not going to use these components. I'm going to drag that on to that mesh if I can. Maybe not. Let's call this one foam or wave. I'll call it wave base so it matches the object. Back to our material. So we've got wave base. There we go. Yellow. And let's make this a kind of bluey white. It's a crazy noisy sort of thing. So let's go back, have a look at this mesh. It's a little bit too nuts. Maybe this one was working a little better. I think it was a little bit less detailed. Just waiting for that particle fluid surface to calculate. I find I do have to be careful with the interactive renderer. Like, I do notice that it crashes a bit, especially when it's like updating heavy geometry, or I don't know, it's just something about it. I don't really like using it because I find it a bit crashy. But it is good, so you know, it auto updates when you make a change. But yeah, I don't know, I just found it to be a little bit buggy, so I do tend to just find myself hitting the render button instead of using the interactive one. You can do it. Hopefully it doesn't crash. Dun, 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 dun. Can I hit escape? Oh boy. Graphics card, you know, it certainly does make a big improvement for doing this GPU stuff. I think a lot of people expect that when they get a good graphics card that it will make everything in Houdini faster. But the fact is that it actually doesn't. A lot of what's done in Houdini is GPU based, so no, it's still it's back. It's just kind of stuck generating this mesh. So yeah, it's it's something to be aware of. Is like when you upgrade your graphics card, you are going to see an improvement, but you're only going to see an improvement in certain areas. And things like this, for example, they're not graphics cards, so it's all down to your CPU at this point and your RAM. Graphics card is good for certain things. It's good for rendering if you're using the GPU, but if you're using Mantra, having a good graphics card, it's not going to make a massive difference. So yeah, it's good to be aware of those things when you're looking at graphics cards, or if you've bought one and you're like, why isn't it working? I think that's a common thing that I hear from people is, or they think that if they get the best graphics card they can, that everything is going to be better, but it usually doesn't work that way. So I'm going to add some smoothing to this mesh, make it a bit less kind of porridgey and a bit smoother, hopefully. And I could take the resolution down a little bit as well, probably, to just make this run a little bit faster. We've lost all of our little kind of droplets, but we could also render those as particles as well. so that we have, you know, the kind of best of both worlds there. So wait for this to finish. It's super slow. So if we take the voxel scale up maybe, or the particle separation as well, if I take that up to 0.025, this will run through a bit faster. But the other thing that, you know, that may make this go faster as well, if I hit escape and hopefully it'll come back, is to trim this down. So that's probably why. So this one I'm actually not utilizing this group here that I removed everything that wasn't inside. So also this is a different flip sim to what we were looking at previously. This one, Flip Sim version 3, I actually didn't put the wave in there as a collider, so you can see there's a ton of stuff behind the wave, which is, you know, doesn't need to be there. So I will run this through that group and blast as well, and then we'll just have that to deal with. So that should make a significant improvement to our particle fluid surface, because it's not having to mesh anywhere near as much. So it's really good to, you know, try and, there we go, look at that. Nice and fast, and that smoothing and lower resolution actually, and just even removing all that stuff has improved the look. So that is going to work a little bit better. It's, you know, it's a little bit low res, but I think that'll be okay. So we've got our wave base on there. Oh, I think that's right. There we go. Okay, let's have a look. Not that one. This one. Nothing. Great. Where's my render flag? Surface polygons. Let's make sure. Yep. That's weird. We were saying it before, but we probably shouldn't have been, because I hadn't even added it to here. So that's odd. Anywho, hopefully we'll see it come through now. Maybe I need to hit that again. So this is the way it renders with the bucket. This is the way it renders when you are not doing the interactive. This is the way I usually like to do it, because it also shows me exactly how it's going to render when I hit render to disk. Whereas the interactive, you know, it's a bit noisy, it takes a while to resolve. It's a nice quick way of doing interactive stuff, but it also kind of, it doesn't show me exactly what I'm rendering. So again, without these things plugged in, we've got this, you know, super refractive thing. But if you remember, what we were doing was we were bringing in the vorticity, running it through a fit and a ramp. So we can do the same thing. So we're going to use that RS user, color user data, or scalar user data. So I think it's vorticity that we're using. So we'll use the scalar and vorticity. We've got our RS change range, like that. And let's just go and steal our values. So we had 30 to 120, and then this was our color ramp that we were using. Copy that. 30 to 120, RS ramp, paste values, and that one can go into refraction color, and then we've got our refraction weight, so that's this one, intensity, and that's that one, copy parameter. So it's kind of cool that you can do that, that you can set it up in Mantra. If Mantra is kind of more familiar to you, then you can set it up in Mantra and then just work on trying to figure out how to bring it across, you know, how to make it work for Redshift. So I think I can see those colors there, but it's very dark because it's getting shadowed. And we also don't have this component. So we're missing a couple of things. We're missing the roughness, and we're also missing this emission color. So that will make a big difference as well. So let's copy parameter on that. Duplicate, paste values, and let's have a look for that emission. So I think it's under overall. There it is there, emission color. And if we go to the overall tab, here's our emission color, but we also have emission weight. So we can turn that up to 1. There we go. So I'm not really seeing anything there. Let's see vorticity. Maybe this is not really working. Let's try RS point attribute. Oh, let's just double check as well. We do have vorticity on there. We do. Let's just check with our color as well that those ranges are accurate. So 30 to 120. Oops. So that range probably is not giving us much. So let's go 5 to 30. So this simulation has some different kind of parameters. Let's try 5 to 30 in there. It's always good to check. Check your values that you're using. So 5 to 30. Hey, there we go. Now we're seeing something now a little bit clearer. So let's have a look at what settings we've got here. We've got our refraction. You can change the refraction type. You could turn off flick to reflection so that you can control your index of refraction and make it specific to that layer. I'm not seeing any emission coming out here. So let's see, we got 5 to 30. Emission color is emission weight is 1. Emission color. Let's take that down and see what happens. Oh, there we go. So yeah, our ranges are just kind of a bit out. So you can see now. There we go. We're kind of getting those more sort of foamy, splashy elements. Maybe we'll just make this ramp much sort of greater like that. These colors I'm not loving. I mean, they don't match this sort of coloration either. So you know, we could go and change that. Make it sort of match what we have in the main wave for starters. Might work a bit better. And the roughness we're not overriding at the moment either. So if we have a look, we've got reflection roughness here. That's just going from a fit. So actually that fit is doing nothing. So we could just drive that by this RS output here. Or if we do put it in an RS change range, we could take that input and then just, yeah, we could have minimum roughness as well, so that this actually is rough all over and it's not fully transparent, which maybe makes a little bit more sense. This refraction weight as well, you know, maybe we don't have it fully refractive. Maybe it is kind of a dark and sort of less transparent effect. And this one, you know, maybe is not transparent at all when it gets to the foamy section. There you go. So you can see how that's affecting it. So, you know, it's interesting to play around with these things. You can get some very interesting and specific sort of behaviors. Now, this isn't utilizing that blur that we put in there. So let's render from, oh, we don't even have it in this file because this is the one that I opened in 18. So let's put that attribute blur in. And before I hook it up, I'll set it to vorticity, because when you hook it up with P and a really dense mesh, it's quite heavy. So I'll plug that in. Let's have a look at it on the color so we can visualize it. Oh dear. There you go. There was a hard crash. So that sucks because I didn't save it. But that was a hard crash with the interactive thing. I think what it was trying to do was, it was trying to update, and I was trying to do something. So that is why I don't like it, because it crashes, and it doesn't throw an error. So that sucks. But it's not the end of the world. It's not like I lost a whole day's work. But it should, I should have saved. I usually do save whenever I start playing around with rendering, because of that fact that once you get into rendering, and certainly if you're using the interactive stuff, it's quite prone to crashing. So it is always a good idea to to save while you're doing it. Let's just have a quick look at what else we can set up. So that sucks. I lost that, but I'll go through and set it up again at some point. But let me have a look and show you some other things that are kind of important with Redshift. And we've got other elements here that are like the particles and the volumes. So let's have a look at those. I'll just set this up again quickly. So I'll go RS Dome, go and grab that light again. Here we go. And let's take a look at doing the building spray, or the wave crest actually might be a good one. So if you have a look at the wave crest, we'll go, I think we're at 48 roughly. Camera 5. There we go. So we've got that wave crest there, and we've also got wave crest or wave surface foam, which is the stuff on the surface. That would be a good one to look at, as well as crest foam, which is a volume. So particles and volumes have specific kind of requirements with Redshift. So RS Light Dome, wave crest, let's get rid of the wave foam material. So if we have a look at that, that is just a principled shader. So let's create an RS material, and we can kind of duplicate the settings that we have on here. So we've got just a white, we've got roughness, and a little bit of reflectivity, no transparency. So it's a pretty basic shader actually. It's just white, half roughness, half reflection, and that's it. So let's call this RS wave foam and apply that. Disco Tsunami, that's right. It's my 80s tsunami. And we could probably apply the same thing to that. Let's have a look at that shader. It looks like it's slightly different, but exactly the same. Oh no, it has a little bit more reflectivity. I guess that's the change. And it has some emission. Oh, they have emission, both of them. So let's add some emission. Overall emission weight, 0.2, emission color, white. Okay, so we'll apply that to both of those things, I think. So we'll go wave surface foam, RS wave foam, and that one has the RS wave foam as well. Okay, so because this file I did not originally set up in 18, it is missing an important component for Redshift, which if you, in the viewport, hit tab and type obj, it pops up this obj palms, object parameters. Hit enter, and you will see that it adds it. I didn't have a node selected actually, so let me do that again. You have to select the node, object palms, and it adds this Redshift object to the tab. So if it's not there, that's how you can do it. And this has Redshift specific parameters. So these are particles that we're trying to render. So we want to go to the particles tab and turn on render object as particles. And then it's going to utilize the p-scale attribute that exists. So if I bring that over to this screen, we've got p-scale. So it's going to utilize that, but you can opt to ignore that and just set a scale yourself. So let's go and do this all again. Always fun when you have to redo everything that you've done after a crash. Camera 1, camera 5, objects. Let's just do the wave and wave crest, wave surface foam as well. There we go. So that'll be okay for now. And then we've got candidate lights. So we've got our RS dome light. I haven't created the spotlight, but I can. Might be all right without it. And we've got our wave here. So let's go and I'm not gonna bother setting that coloration up again, but I will just give this a kind of, you know, overall. Let's drop the reflection. Let's just give it a kind of greeny blue this time. There we go, something like that. Even the refraction weight, we could just do 0.5. We'll put that on the wave and open the render view. Choose our ROP. Fingers crossed. Hey, there we go. And look at that. We've got our, looks kind of cool. It looks like it's actually on the water with this HDRI in the background. So there's our surface foam. Or our, not our surface foam, our kind of spray. But we're not seeing our surface foam, which I did add. But again, this doesn't have the Redshift object parameters, so let's go and add those. And under particles, render objects as particles. Hopefully that will add those in. There we go. Cool. So that's, you know, that's just something that you need to do every time when you're, you know, when you're setting this stuff up. That actually looks great without those buildings. Those buildings, you know, they kind of they're casting a lot of shadows, so it does kind of interfere with a lot of that stuff. So let me hit. I'll go interactive at my peril, and let's make the wave slightly more reflective. There we go, and we've got our wave foam here. So, you know, it looks a bit weird here under the shadowy section, which is down to our emission. So, yeah, if I set that to 0, for example, you'll see that we get much more realistic shadowing going on, but we've also lost the sort of brightness of this stuff here. It's probably why I had 2 separate ones, so I might duplicate this, call this surface foam, and have a different emission. Yeah, maybe I'll make that one 0.2 and apply that there. So RS wave. Surface foam. There we go. There we go. So now this one has some, you know, shadowing, which is cool. And this one's quite bright. So that kind of works well. And what else? What else? We've got our foam as well. So we've got our crest foam here. So if we turn off, go to our out. I think these are in candidate. So if I turn these off, wave crest, that should disappear from the render. And we can have a look at our crest foam. So again, oh no. Wow. Redshift. Interactive renderer, I tell you. It's terrible. Never had so many. Well, I have, but yeah, this is why I don't use the interactive. I keep saying it, but I keep doing it. I'm a fool. Don't learn from my lessons. All right, so let's try again. I just want to show you the consideration for the foam, the volume, because that requires a different set of parameters and a few other things as well that could catch you out. So what happened? Crash. Hard crash. Always fun. So we'll open it again. I've been not using Redshift. Look, it's not that bad, but the interactive rendering really I do find buggy. So just, you know, it's just something to be aware of. And avoid if if it happens. But like sometimes crashes as well can be just related to your specific hardware setup, and that, you know, might not happen for other people using it. It might just be my graphics card or the drivers or something. I don't know. It's like, it's one of those things that you just have to kind of work out on your own machine, and, you know, hope that you can figure it out, or work out ways that it doesn't crash. And that's just kind of what, you know, what you have to do. Hey, Mitchell. Yeah, aren't they? Aren't crashes the best? Can't tell you how many times I've forgot to save and, you know, lost everything. Whole day's work or something. It's devastating. But, you know, you get used to it. Yeah, it's way better than, you know, than it used to be. Back when I, you know, I've probably said this before, but back, that's the spirit, Audrey. Back when I used to use 3D Studio Max, you know, like, we would have a whiteboard at work and our names on it, and we would just mark like a line every time that we had a crash. And I think in one day I had 100 crashes, and that's just like, it's almost impossible to work when you're having that many crashes. So, you know, it's not that bad. Yeah, exactly, Mitchell. It's the same. Autodesk, yeah. Call it auto death because it crashes so often. So I don't know. I'll give this a wave material again, and I'll just duplicate this, and we'll go full reflection, white, no refraction. We'll call this one spray, and be done with it. So that's our wave crest. RS spray. We've got RS wave on there. And then we've got our crest foam. So, like I said, this is a volume, so it requires different parameters. Let's just go and give our object palms to these objects as well. So this one's render as particles. This one, just check what we've got here. We've got a single density attribute. And let's give the object palms to that as well. This one is not going to be render as particles. It's a volume tab, but we don't have to change anything on here. But what is important is the materials. So we're going to use an RS volume node. And you can see that this has density on it by default. Now I usually plug this into a Redshift material. These names can be tricky. But this is like an output collector for materials. You can see it has inputs for surface, displacement, environment, and volume. So I usually plug that in there and then apply it like this. So I'll call this material foam and apply it. And there it is there, foam. So let's have a look. Did I create my dome light? No, I did not. Let's create it again. RS dome, light, dome map. One more time. I swear, if it crashes again, I'm not going to do this. I'm not going to do it again. RS dome light. Okay, there we go. So, out. Redshift. Redshift drop. Objects. Wave. Wave, crest foam, and that'll do for now for testing. And we've got our lights, open render view. I'm just going to use this button instead. Okay, so that's not the right render, that's not the right camera. I need to go to my main, set my camera, give it 5. Okay, cool. But, so you can see we have a volume there very subtly, but it's black, and it's creating this darkness here. One thing that always gets me when I'm working on volumes is I often forget that you have to set on the lights, they have this volume contribution. So, contribution scale, 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. there you go. So you can see now that we're getting that volume showing up. I always forget it when I'm trying to... Look out, a tsunami. I did watch Titanic 2 trailer that you sent me too, Audrey. My god, that looks amazing. Yeah, it gets me every time, Mitchell, that volume contribution. I'm like trying to render my explosion or my smoke or something, and like, why isn't it working? I've done everything, and then I'm like, of course. That little pesky contribution scale. Shadow, also, you have the ability to add transparency to your shadows, so you can do the same thing like what you can do with your mantra lights, where you're changing the shadow kind of intensity. You can do the same thing with the transparency here so that you don't get super intense shadows. It's giving me some pretty dark shadows here, but that will go away when, well, let's try adjusting some of the volume settings. So I always forget. These names just really annoy me. But you can see when I do that, I get brighter density, and then absorption coefficient should give me slightly more dense as well. There we go. So it's getting a bit denser, and let's just up this. We only have an environment light in here, so there's no super directional light. Yeah, Titanic 2. Wow, it does. The trailer did make me want to watch it, but man, it looks bad. But very, very, very funny. I can't believe that they made a second one. Well, it's not. I mean, it's just a standalone movie. It's not like it's made by James Cameron or anything. But yeah, man, hilarious. As if you would call your boat Titanic 2. Or even say that it was unsinkable. Just sounds like a bad, it's bad luck waiting to happen. Wave crest. So we've got RS spray. Let's take a look at this. We'll add this one into the mix. Objects. Wave crest. You know what I should do? If history has taught me anything, I should save right now. There we go. Alright, so that basically the boat is underwater, but first falls from a gigantic wave that wouldn't be humanly possible. It's hilarious. Yeah, I mean, it just, yeah, it looks, it's like in the trailer, it's like in the same spot at the same time on the same day. I can learn from my mistakes, Mitchell. So we also don't have motion blur on here, so we should do that. We should add motion blur. Go to Redshift, motion blur, enable. We want to enable probably both of those things. I think it's maybe just more so mesh deformation that we want. We also want to make sure that we have it on our settings here. We've got mesh deformations from velocity attribute. So that's kind of the one that we want to turn on. We do have this one on as well, but yeah, this one will use the V attribute that's present, which usually, when we're dealing with particles, that's usually kind of what we want to use. Object palms on that. I'm not loving that dark line there, but I haven't set up my material properly on my wave, so that darkness at the top would actually be rendering white anyway because of that gradient that I created. So that's not too bad. I could also trim my wave so that it, it didn't kind of poke out through the foam like that. But there you go. So, there's a couple of other things to kind of think about when you're working on an effect like this, where you have particles, but you also have foam. Let's add our... How long have we got? 4 minutes. Should be That's an eternity with Redshift. So what have we got? We've got our mid-ground buildings, our BG buildings. What's in foreground buildings? Maybe the whole kind of set is in there. Let's have a look. Nope, nothing. BG buildings. Let's have a look. What have you got? Ah, there we go. There's the whole kind of set. So let's render that. Okay, MG buildings. Again, you know, this whole business of... Oh, there we go. There's some cool stuff. Let's have a look at that. So we need to reverse. Yeah, that's right. It's funny, like, yeah, some things in Redshift are fast, but then other times they aren't, which, you know, can be a little bit annoying. Now, here's an interesting problem. I shouldn't have selected that. I don't know what that's doing. But I guess there's a lot of geometry in there that's loading in. Here's an interesting problem with these buildings where I've put the reverse down, but it's flipped the building, but reversed all the other stuff. So how do you do that? How do you reverse just one component? You could isolate the building and reverse it, like I have isolated that building. But you can actually also use a polydoctor to unify the windings of the polygons. So all these windings are different, but what you want to do is unify them so they're all facing the same direction. The polydoctor does a whole bunch of things. So usually I will cancel it and turn off the things that I don't want. So I think it's under the topology tab, and correct windings is what I want. So I'm going to turn that on. Because of this model is not like an amazing model, there probably are a lot of problems with it. So you can see it's going through and detecting self-intersections and a whole bunch of other things. I think the reason I'm leaving it on is I think turning one of those things off does stop this from happening. But yeah, you can turn off some of those things and leave the one on that's important. But I'll just let them all go, see what happens. Hopefully we'll get reversed windings. We might end up with them all being blue, but that's good because then we put a reverse down and they all end up being the correct way. So yeah, it looks like it's the self-intersections are the problem with this, which is typical of a mesh that has been kind of modeled, not with destruction in mind. It looks like that hasn't helped at all. Let's go ill-formed, ignore. Topology. Oh, let's set that to repair. Why are you not working? Maybe I should set to mark. So mark won't do anything, but it will mark those areas that are non-manifold. I don't know why this isn't working. Let's have a look. Maybe it probably is this, like this ill-formed section I do need to have turned on, I think. I could take down the max passes as well. Maybe that might help speed it up. Well, that does make it go a bit faster. Come on. I was doing this just the other day, and I do remember I had to fiddle with it to get it working, but I eventually did find the correct combination of checkboxes and drop-downs to make it work. Let's see. It's slow because there's a lot of geometry, and there's probably a lot of bad geometry in these models. Come on. Well, made a liar of me. I don't know. I guess maybe I should set that to repair as well. Yeah, I don't know. I'll try and figure that out again. I'll let you guys know next week if I work it out. Because it's really handy. I mean, you want everything to be unified, and quite often, because these models have been, this one particularly has been stitched from lots of different assets. Some of them are facing the right way, others aren't, and you can see when you bring them into Redshift they render black. So I'm trying to unify everything so it's all pointing the right way and all the normals are kind of correct. So let's give it one more chance, and then I'll just abandon ship. I used up my 4 minutes playing with this silly node. All right, screw you, Polydoctor. Medium buildings, background buildings, ground plane. Let's get all this stuff in there. Forced objects, I'll just add them in this slot. Mid-ground, foreground, ground plane. Yeah. Oh, not foreground. Memory of a fish. Individually select the polygons that need to be reversed. Yes, well, that could be an option. I mean, yeah, that, like, to just reverse the building, it would be easy to just isolate that and reverse that one. But, yeah. Look, if I couldn't figure it out, I probably would do that. But there is a way to do it. Sometimes the brute force method, you know, and by brute force I mean just manually doing it, is faster than messing with something for a day trying to get something to work. Alright. Why aren't you reframing? There we go. Save. Hit render. See what happens. I didn't give these material, I think. Maybe they won't render at all. That would be such a pain. Yeah, look, yes. Some things though, like, I don't know, I do tend to do a lot of manual selecting and stuff, and it is painful, but it's also like not that bad, you know. So what have we got here? Material, RS building, and sometimes it's just the fastest way rather than, like I said, messing around with something for ages. It just, you know, takes me 10 minutes or something to manually select some stuff, and it might take someone half an hour to an hour to figure out some kind of node, like, you know, how the Polydoctor works. Then, you know, it's kind of like make my selection. It's not procedural, so if you change something you might have to do it again, which would suck. But yeah, sometimes, you know, sometimes those manual approaches, they just get the job done, and you can move on. Right, turn my wave back on. Take my reflectivity down. And away we go. So this, you know, I mean, the Redshift one, we've had a lot of problems with crashing and stuff today, so there's a lot of work to do. This needs a lot of work, you know, it needs a lot of work to get it up to scratch, this shot. And I'm not gonna, you know, I'm not gonna finish it off in these streams. I think this will be the last stream that I do on this one, unless anyone has anything specific that they want to talk about. Because it's going to require a great deal more work, and that would mean, you know, like a 20-part series or something. I think what I will do is probably finish it off at some point, and then, you know, show you guys what it looks like, and we can talk about the processes and the things that I did or the things that I changed to make it work. I think there's some really good things going on here. But there are also things that, you know, need a lot of refinement. The behavior of the particles and the look of a lot of things, you know, this flip sim needs a bit of work, and just trying to sort all that stuff out. So, you know, I will do that stuff at some point. Not that I, you know, am using this for anything, but it may turn into a tutorial for CG Spectrum at some point. yeah, there's a lot of work that goes into a shot like this, and this is just, you know, me working at it for 2 hours a week, which isn't really enough to, you know, to kind of refine a shot to a high level. But I hope, you know, I hope it's been informative. I hope you guys have learned a few little tips and tricks, and if you do, you know, an effect like this, please let me know. Tag me in the comments, or, you know, yeah, hit me up and show me what you've done. And yeah, if, you know, if there are things that are in these streams that I haven't kind of covered, I don't go super in depth in a lot of things. I do try to explain, you know, most of what I'm doing, but these aren't designed to be full on step-by-step tutorials. That's what, you know, the courses are at CG Spectrum that we offer. We teach you how to do this stuff from scratch and how to use Houdini from scratch. So if those are things that you're interested in, then you can check those out. But yeah, I think, you know, if there are ever questions, I would definitely try to answer them if you have them about specific things that I've done or specific workflows that need more explanation. Please ask. Mitchell says, probably won't be able to watch live, but I'd like to see some sort of scene where there's underlying structure to a model like a skeleton. Ah, cool. Yeah. Let me add that to my list. Yeah, I really like doing those types of effects, Mitchell. I think that could be cool. Let's say underlying skeleton, muscles, and gore. I like it. I really find, you know, doing that sort of stuff, even though it's kind of disgusting and gory, it's a lot of fun to do, you know, fleshy, bloody, gooey stuff. It's good kind of effects stuff to do, you know. There's a lot of effects challenges, and you end up using a lot of solvers as well, which is kind of cool, or coming up with interesting SOP-based methods. And I think that stuff is a good, you know, it's a good small scale effect. You know, I was talking how I like that sort of stuff. I just realized my camera's frozen. I'll switch to camera 2. There we go. Not quite as nice. Yeah, I really like doing that small stuff, you know, the smaller scale, human scale things is, I think the challenge is, you know, it's a really good challenge. There's lots of cool stuff that you can do, but because it's smaller as well, you need to think about it in different ways. I think, you know, with destruction and things like that, broad strokes, you know, you can get a lot of stuff in there. There's a lot going on, so you don't need to focus necessarily on minute details. But when you're working at more human scale, all the details show up. So you really need to, you know, get that stuff looking really great. So yeah, cool. Good suggestion. And that's okay if you can't watch live. I'll forgive you. All right, guys. Well, it's 12 o'clock here, and it's time for me to go and have some lunch. I hope this has been informative. Please let me know if you have any questions about Redshift or rendering in general. And I'll have a think about what we're going to talk about next week. I probably won't start a massive project again, like I said, but I will do something. I may pick something from the list, or we might do something else in the meantime. But we've got lots of great suggestions, so keep them coming, and I will definitely be working on you know, on something. I've been working on some explosions recently as well, so that might be a cool thing for another stream series. So I've been working on these. I don't know if this plays back terribly well for you guys, but just been working on some nice kind of explosions. Still working on it. There's a few things I'm not super happy with, but yeah, just been working on some explosion ideas and some setups that I think work pretty well. So I might go into that in a little bit more detail. This is also the type of stuff that we teach in our courses as well. So I don't want to teach it in too much depth, seeing as we also offer it in our courses. But I'll definitely go over explosions at some point and teach you guys some cool tricks. There's a lot of cool stuff you can do. And again, you know, you can see that shader. I'm actually using that sort of scattering shader in this stuff. So you can see that coloration coming through where it's not just grayscale. It has this kind of subsurface type feeling. This color, I went a bit crazy and ended up with purple, which I don't love. But yeah, you can kind of see that coloration there, that nice sort of scattering. And also variation in tone and color in the explosions or the smoke that's coming from them. So I can definitely show you guys something like that in the future. But yeah, all right, guys. Well, I hope you all have a wonderful day, and thanks for joining me yet again. Hit like and subscribe if you haven't already. I know a lot of you guys have, and thank you. I really appreciate you guys tuning in every week and joining me and keeping me company. So yeah. Thanks a lot. I'll see you guys next week. Bye.